Alrighty, I think we have audio. Looks like everything's up and running. Hi everybody. Last time I was mucking around, I think, with either nominal sets or relational programming. I figured I'd get back into the relational programming side of things. I did a bunch of work on it up in Iceland while I was visiting there for this sort of impromptu hackathon slash coding thing that we kind of half organized. I'd like to thank the folks who were up there who arranged for me to have a place to sleep and what have you. I'm trying something new, seeing what if having a thing above my head that tells people what I'm working on, at least when I don't actively need the screen real estate, if that can help kill some of the chatter about folks coming into the channel or the chat here and just saying, hey, what are you working on? And that derailing us every 20 minutes. We'll see. If nothing else, I can sit here and dump more content into a little FAQ above my head and get the ability to point to things and then move on. Still getting used to the new machine, so. What do we have here? I should add FastTags support or something if I'm going to be trying to do everything in one monolithic Vim session. What do we have here? FastTags. Haskell FastTags. Wow. Switching between monitors, I lose some resolution. Hold on a second there. Thank you for scaling that ridiculously, Windows. FastTags. You know, I'm just going to do it. Might as well mingle my environment. Git clone. Realize I'm off fiddling with tooling and not yet to the interesting parts, but it's got to happen sometime. Might as well happen on stream where it can be recorded and watched by a whole bunch of people who will critique every little thing I do. How is everybody tonight? I hear crickets. Oh well. So the main thing I've got with that's changed in Guanxi since the last time I think I did a stream was the Propagator stuff has been tested and actually works. Oh, not quite sure why. FastTags. Oh, it probably doesn't have the build tool depends. In other news, I think the Black Tiger here set up something with Puffin Fresh. They were fiddling around with adding chat emojis or something. I don't know the status of them. I believe they work. I don't know what the Twitch convention is for spitting them out in chat. That would apparently be it. Yep. So they coordinated a couple of images that they liked and managed to make something happen. Do we take PhD student interns in any capacity at Mary? As far as I know, they have a pretty good internship slash what have you program. When I was there over the summer, There were like 10 interns running around. So I would expect yes, actually, Lorax. The person to reach out to would probably be Buck Schlegeris, or Buck Schlegeris. See if I can pull up the. You can find him on intelligence.org. Cool, install Alex. Let's see what we have here. I mean, I'm happy to chat further about it, but I don't know anything about the details of the internship stuff. So we have Cabal install Alex. That's done. Cabal install FastTags. Just brute force installing it. I can remember the tricks to make Vim automatically rebuild my FastTags on file save or something. Oh no, not a problem at all. And if I remember right, there was something that you needed to use with FastTags, like a little shell script or something. Basically just getting CTag support so I can quick jump in Vim to functions rather than have to stop and reload. Where's the repo? Come on. I did click the button. Oh, that's because I clicked on the get. Where am I going here? There's like a source test. Where's the little init tags or something? I think this has my patch in it. I sent a patch in a while ago. Way to avoid standard in for no arguments. Bugger all. I used this at one point. FastTags minus R dot. Should be in the meta tags file or something like that. There we go. This looks like a bunch of stuff for Munchie, although it's creating stuff for the work in progress directory, which I don't want. I just need to tell my Vim setup to actually use tags. Yeah, I remember where to tell it to go look for the tag file. This is me caring about. Where's the setting the tags file name in my vimrc? set tags. There's set tags, and then you can have it go out. Up and up until it finds it. That looks like it. Config and vim init vim. That looks plausible. Can I do source tags all the way out? Because otherwise I'm going to not find it when I'm in the root of the project, which is where I want to be sitting. Or I'm source tags. /tags. Make sure that Git ignores it. Does. And realize this is watch someone flail around with their build environment for 20 minutes rather than write any code. But has to happen at some point. Control M is going to cause problems with terminal emulation. Quantumplation, no, you've so far missed me mucking around with adding FastTag support so that I can quickly jump to definitions inside of Guanxi. That's all I've done so far. We got tags, and then I can say FastTags, and that's our source. And I used to have a fancy thing so that whenever I would save, it would rebuild my FastTags for that file in particular. But I don't think it really matters. Yeah, source, ref base, tag jump to cell or signal. I don't have signals anymore, I have vars. There we go. That makes it a lot easier to get around. I don't remember the key combinations for manipulating tags. It's been a while. Oh, it's like control right breaks. Yeah, there we go. So if I'm hovering over, I don't know, one of my own definitions like that, it'll jump directly. Cool. I got navigation. All right. So what is here? The main things that I've changed are, well, it works, I believe. GHCI, source FD, Monad, I think has a little example, not really all that exciting. Well, new build, Guanxi, let's make sure that actually compiles. Well, new exec. And that's Monad. Oh, bugger all. What's the magic incarnation to, incantation to get this thing to go? Cabal new REPL. FD Monad. Main. example. Hey, it's good, it works. So that's it, running a toy example with actually making a couple of finite domain variables and comparing, finding all the solutions where x is less than y. Not exactly the most auspicious start, but it's the first example that worked, damn it. The finite domain monad here puts together a bunch of pieces that I had to build along the way. In particular, I think the major change since the last time is that I have all of the cell and propagator machinery working. I think the main difference is that as a matter of emphasis, it's logic programming with a focus on not using cut. And the reason to avoid cut is that cut tends to be non-compositional. If you use cut in your logic programs, then you can't generally build bigger logic programs that use those things as sub-goals, because then you'll stop backtracking in the larger context. Oh yeah, that's the other thing is I've turned off I switched to low latency streaming because I found the option now that I guess they've rolled it out far enough. So hopefully things should be much easier for interaction. Because before we had like 20 or 30 seconds worth of latency, which was terrifying. I'll unpack that a little more later. Larf, what's the primary motivation for using Haskell? That I can get out of bed in the morning and enjoy programming with it. That's my personal motivation. To be honest, I enjoy working in Haskell. It's a good language for writing code that you have to reason about that you still have to run at the end of the day. If I need to try to kind of balance my power of reasoning about code against the number of eyeballs I can get on that code, Haskell is kind of a good sweet spot for me. Yeah, it's sort of the principled version of logic programming. Hello, Lambda Coder. So let's see. So what are the new things here in this implementation? So last time I think I left off, we had built like a key monad, which defined this key data type, said we've got the ability to basically hold on to a mute var proxy, although this thing relies on what I've now learned are unsound problems. So type role key nominal freaking nominal should keep that in check. Because currently, STRAFs are coercible in their last argument, which makes sense because they don't rely on it being nominal. Language role annotations. And then I can either just not export this. Yeah, so this is, I'm definitely shifting the focus away from, so mini-canron, I could implement like a naive mini-canron fairly directly, and I have a toy finite domain solver in like the work in progress directory in the repo. It was more or less just a toy to get things going. My main emphasis is going to be on trying to leverage abstract interpretation techniques, conflict directory clause learning, all the things that Canron doesn't really do because it has to have this super minimalist core. And that's sort of the emphasis, I guess, that's kind of being bandied about above my head. We have the role annotations on key. That should make sure that both arguments are nominal. So, where was I? Tag jump to key. 2. So yeah, so a key is just a reference holding onto a proxy, which then lets us lie and say that we could never have built it any other way. And then given two keys, I can compare the two mute vars for equivalence. Mute var is just STREF in the primitive library vocabulary. So primitive provides us with references and arrays that can work both with ST and IO. And so given keys, I built on top of those this like cheesy little ref system, where a ref is just a key and a number, and the number is used to look up in a map, which is the state of the monad. So reference environments holds onto these boxes, which were built in the key module, which was also in the original article by Atsi Vanderplug, which I mentioned, I think, last stream. The only problem with this arrangement is that dragging a browser window up here is a nightmare because the screen resolution changes. Atsi Vanderplug key monad. Here we go, the key monad. I will dump this into chat for those who are following along at home. This is the original paper. They have this key data type and some key monad and the ability to create new keys and test for equality and then run the key monad. This test equality happens to be the same test equality that we need in data.type equality. So I leveraged that after somebody else pointed it out last time. And these are the unsafe courses that make everything go. And well, I've never got Hugh. Yes, definitely. We're trying out the new low latency settings to see how much they help. And so far, the feedback is good. So let's see. So given tags, we've got our references. Our references reference, like we just have this environment, which is, so previously I was using a fancy environment. Right now I had a little glitch in it and I didn't really have the time to fix it when I was actually trying to work on it. So I just replaced it with a little hash map. So it's just a map from integers to values, and then a size so I can allocate fresh elements. And this lets me just get away with like using and all of the machinery from Lens to directly work with it. It's basically just a map with a fresh variable ID. So if you see env anywhere in this code, that's all it is. So a reference environment is just like a map from IDs to boxes and a fresh box supply. Allocating a box just creates a new box and then creates a new key, and then the references themselves hold on to the default value, like the if you haven't written to this with a new value. And when I use ref to say given a ref SA, yeah, I can give you a lens from S to A into any reference, anything that has a reference environment. This is using the class E lens stuff. What I'll do is if I go to look up the thing and it's not there, I will just use the value from the reference. Otherwise, I will go through and do the proper test equality. And then when this thing is done, it's going to write back into S, the modified thing all the time, mainly because I don't want to actually have to require the ability to test for equality. So this means until you touch a reference the first time, it doesn't actually have to be written into the environment that we grow as an explicit functional thing, and we need it to be grow as an explicit functional thing so that I can have non-determinism and backtracking and all that. If I didn't do that, if I just tried to use raw STREFs, then I wouldn't be able to have list-like effects as well, which is what all the monad logic stuff's for. So the idea is you have sort of this logic T layer built on top of ST, which is enough to give me this key functionality, which I can safely use across universes where universes whenever I'm using the OR of alternative. And you can build references and use them as if they're ST references, even though you're in this list T-like setting. So that's what references are here. So you can create new references. Just like this, just read it like new IO ref. You can read ref, you can write ref, you can modify ref. And then there's this ref lens that works directly on the ref environment. And the monads that I'm going to be working with are going to be instances of monad state such that they have a reference environment for the appropriate key state for that monad. So that lets me sort of once and for all like write the concept of a reference down and then work with it. Then right now the propagator code's kind of a mess. I started in another little toy branch on another machine here, playing around with this. I'm probably going to gut a significant portion of this code, at least as it is visible to the user. Because as far as I can tell, the user never needs to actually see a propagator. They just need to see the ability to propagate. So you need this new propagator underscore function and the ability to construct a propagator. They never need to see this aim. Like, half of this stuff can clear up. And a var at this point in time is now lobotomized to the point where it's more or less just a signal saying, hey, look, something happened. So right now, propagator is what to do when this propagator fires. What are all the cells, what are all like the join semilattices that it's reading from? What are all the semilattices it's reading to? That'll let me do the topological sort later. And some unique ID so I can compare propagators for equality. A cell has the set of outbound propagators from it so that I can fire them all. And a strategy for what it should do when everything has gone quiet and we're at the end of the entire program and we want to ground out all of our variables to make sure that we actually found a solution. That'll make sense when I get to like finite domain variables as an example. And then async was me playing around with the design. I don't really like it. I'll probably rip it out into its own module because it can be built on top of cells and doesn't need to be exposed here. The cell environment is sort of it's a map where I can look up cells by ID, a fresh propagator supply, all of the propagators that we haven't fired yet that are currently active, a reference environment, and a flag telling us whether or not we actually want to delay firing of propagators. So one of the things that works with propagators is it doesn't really matter what scheduling strategy I use. Like the whole point of working with propagators is because you're working with these join semilattices and monotone functions, that any scheduling strategy will yield the deterministic answer. Hi, V. The difference is that if I can batch up more things, then if I had a topological sort on my propagator network, which storing the source and targets above would let me, then I can do better. That's really what it's all about. So a lot of the stuff for logs and stuff like that has been punted out into a separate module so that I can use it on particular kinds of cells and stuff like that that actually can take advantage of it. So you'll notice that the cells have lost everything about what their actual like contents are. Like the cells don't even know that anymore. So they're really just signals. I'll probably change the name of everything here. I don't really like the idea of a var. It's just too generic of a name. So it's like a signal. And then a cell environment is basically just this thing where we have the cells in them, the fresh propagator ID, the pending flag, or the pending set of propagators, a safety that says whether or not we should actually fire propagators now, and a reference environment, which is sort of our direct superclass. All right. So we can create new variables, tie them to scopes. So the scope thing is just locally turn on the flag and then pop out of here. In theory, I could have really gotten away with using a reader discipline for setting that flag. Maybe I should have. I'll revisit it. I didn't really want to maintain a separate reader component just for this one thing. So right now it's bolted into state and I use it under a reader discipline. It's a directed graph. A cell is a node and a propagator is a hyperedge. So it's a directed hypergraph. Yeah, so right now the idea is we'll wind up with aim, scope, and fire. You just wind up with scope and fire. And yes, I do a lot of pun-driven development. These things will probably be hidden from the user soon. All right. So now that I've got all this stuff, the grounding thing is at the end of the program. Basically what I want to do is make sure that I go through and ground everything out, as I was saying. So I loop over all the cells, and then any of them that have a cell strategy, I make that run. Now, arguably, this should possibly be done by storing that in a separate map so that when I do the traversal, I don't bother walking into cells where most of them don't have one of these. But I can revisit that later. So I have these finite domain variables, which are an example of this. And they are the pair of a var, which was the name of a cell that the user gets to see. This is the signal-like thing that I was talking about. And a reference that is its content. So like for a finite domain variable, this reference holds on to the set of possible values. And you can create a new FD-var, and it'll grab the domain that you gave it, and the finalizer, the sort of grounding strategy, is to go through and loop over all of the possibilities that are left over and try them out. And then val here, like, exposes in M access to the finite domain variable's value, although if you do this, you're basically giving up and doing guess and check. And then I have this little utility function for shrinking things. It's sort of unsafe. Because if you go to feed it a function that takes this set to a larger set or to a set that contains elements that were not in here, then it's not really a propagator. Yeah, so I'm very deliberately kind of jumping to the punchline rather than trying lots of little incremental things. You're welcome to submit me examples, though. I'm not really personally interested in writing them. Don't really like that. Parens. The wrong place. Is forces this to a value, isn't less than, etc. So now that I've got that, the other one is I have this, the other interesting sort of addition since the last time I streamed is this par monad, which is based on Lindsay Cooper's stuff for par. And this is me playing around with, can I use like a par-like concept for manipulating logic programs? Now, par is this fork join or fork model. It's fork only. It doesn't even bother to join. Where you're allowed to fork off computations, run them, and I think when I talked about my propagator stream here, I talked about the fact that if you built a propagator using par, it was always a valid propagator, which is one of the nice properties of this par stuff. Here, what I'm doing is trying to think of par on these funny kind of references, which are inside a state. So now par is purely a concurrency framework. It's not a parallelism framework. Okay, we can maybe get parallelism across universes, but we can only get concurrency within a universe because we're going to be manipulating big piles of functional state. And what I did was take some of my old propagator code, and then since I have this pile of reference-like things, I built this on top of that. So the par environment is just a queue of tasks to run, and a task is, given a par environment, do something in M that returns a par environment. And I can take a par computation, which is basically CPS'd, so I can get access to the current continuation that yields a task, and I can convert to and from like these little state like things. State par might actually be unsound. I'd have to actually check this logic. This was the first thing I wrote that worked, and then I didn't really look back at it. And so this is just Kant, or this is this is just Kant T in disguise, or Kant in disguise. So this is Kant task MA. So we got applicative monad trans, all this kind of stuff for lifting actions into this thing, and what it will do is how to put it. So the monad for par gives me like 3 different operations. One is the ability to fork off another computation. One is the ability to yield, which is like a green threading within a universe. So like if I have multiple threads, quote unquote, within a universe, I can yield to another one to let that schedule and do work. I can halt, which ends this thread but doesn't blow up the universe, which is distinct from empty, which will blow up the universe even if there are other threads running. So blowing up the universe has basically this path doesn't lead to a solution. Halting, on the other hand, is just saying that I am no longer contributing work towards the solution. So we have fork, yield, and halt as sort of the vocabulary of par. And then the way it's set up right now is I can capture the current continuation, which is functionality that I need. I'm currently using monad Kant. It's kind of a bad fit. I really should make my own one-shot continuation class for this, because I don't want you to invoke the continuation multiple times within a universe. The interesting part here is that unlike par, as it's usually presented, it's possible for me to use the monad plus / alternative machinery to fork the universe, which forks everybody in it, or basically makes a copy of everybody in it. So if I use the monad plus machinery, that's not fork, that's give me a new, like, split the universe, and then everybody in this universe that was going to do work is going to do work in this universe, but I've changed, like, some assumptions about the world. And so the idea is that this lets me write like promises and futures and all that kind of stuff in the propagator framework directly. And I don't have to interrupt my local computation. I can just kind of spin off another thread that will fulfill a promise. So that let me build futures and promises, which I'll show in a second. So a promise here. Now, basically, this is another thing that's sitting on top of the propagator framework. I have so a promise is an IVAR in Lindsay Cooper's vocabulary, it's an IVAR, and this is Lindsay Cooper's variant on an IVAR, where you're allowed to fulfill it multiple times. It has the var, which is the state that I'm going to use for propagator firing. I should probably add a Y Haskell. There, we have a Y Haskell. So the promise variable, the promise val will only be updated from nothing to something once. Is it in the monad par package? I don't actually know where they packaged it, if they did. Package monad par. Simon Marlowe, Ryan Newton. You've got some of the right people. So par has spawn and get, I think. This is a little bit different than the Lindsay Cooper par. Newer libraries that export. Elvish is actually the current one. So in Elvish, she has a par monad. And then she has a tag whether or not it's deterministic or non-deterministic. I'm assuming determinism for everything. Which is a bit of a lie once I start adding some more things, but yeah, she builds this monad where you're allowed to fork and create and read from these join semi-lattice based variables. Although they're not really join semi-lattice based, which is sort of the L in LVARs, as far as I can tell, just stands for Lindsay. But this par monad, par determinism, she's got deterministic and quasi-deterministic. Like I said, I'm just assuming determinism. And her par monad is built on top of like this Chase Lev work stealing deck that I wrote at some point that Ryan Newton fixed up. So if we go to add a parallelism layer, the outside parallelism layer will probably be built on that same sort of thing. So in some sense, her par really should be, for me, a conc, and then I would have a separate par, because it's just concurrency. So creating a promise, all I do is create an empty promise. I can create a promise two different ways right now. One is a promise that has to be fulfilled or the universe is inconsistent. The other is a promise that can go unfulfilled and the universe goes on. When I go to fulfill a promise, basically what I'm doing is looking at the reference, and if it's currently unfulfilled, just letting it through and then firing the propagators out of this value. And then when I go to, if it's already fulfilled, we're okay. The universe doesn't collapse as long as you don't try and fulfill it with inconsistent values. And then I've got this sort of bang bang thing. I don't really like the imperative looking API there, even though bang equals is going to give imperative people fits. Rather than make up a random operator for a niche toy. So unsafe fulfill will let you fulfill the promise multiple times, but trusts you that you fulfill it with the same value. And then demanding the result of the promise is actually the meat of all of this. It's the reason why par is hard in the first place. And was needed in the first place. Notice that none of this stuff needed anything about like monad par. It's demanding. And when I go to demand the result of a promise, I have to first capture my current continuation. Because if I go to read from the reference and it's not satisfied yet, what I'm doing right now is this awful thing where I instantiate an entire propagator, and all it will do is it will read from the reference and traverse it, and then halt. which is probably wrong. I haven't actually tested this. Oh yeah, it should halt. It should halt and then move back to another task or something. So this is the idea, at least. I haven't finished fleshing this out to actually verify that it works. But these are the promises that I was building. And once I have promises, I can move futures. So a future is a promise paired with a computation that's actually going to fulfill it. And in theory, what I've done is I create a promise. I run M of A. And I do this, but I should do this in a fork, which was not possible before. So I should run M. I should make the, I've made the new promise. I'm going to build the future P. And in the meantime, I'm going to fork off a computation that does this thing. That's annoying. Because I don't really want to write the, I'll write it this way, even though it's janky. Fork do. So we start off, we fork off a separate computation that will fulfill this promise. So one of the things I'm kind of playing around with is whether or not I should view each one of these tasks that is coming out of a propagator as something that has been forked. So it just runs and it doesn't need to think about what it's going to do next. So when you create a future, you're allowed to build the future. You're allowed to block on it right now. There's no nice monad for futures and all that kind of stuff yet. But it's starting to feel very imperative, isn't it? Now that I've got this notion of like references, it's like an imperative framework where I've got non-determinism and this par machinery for green threading. I'm kind of liking it. Not so sure yet. But this is sort of the bottom layer upon which I want to build all the other things. Assuming I get the par machinery right and promises and what have you. Actually, Control P. Par promise. Sweet. That fixed everything. So we have promises, we have futures. What else do we want here? Oh, I did more work on getting unification and stuff like that working. So I can start building it on top of the existing machinery. So in ref, I have this rem thing. I have this union find structure that I want to work with. And this is sort of a placeholder for it. It's probably the wrong implementation. But I wanted to have union find so I can build like do unification variables and the like. I'll need to actually put a syntax tree and stuff here. Right now I'm using REM's algorithm, which might be less familiar with folks on the stream. Most people are familiar with path compression and union by rank. REM's algorithm for disjoint sets. See if I can find a good reason to consider it at all. Is this talk by Pat Wary and Blair and Mann from several years ago. And the main thing was that they showed was that out of all of the algorithms that people have for actually implementing union find, it turns out that the ones that everybody believes by common sense to be the best ones are not. Like, people tend to implement path compression and union by rank or union by size and call it a day. But you can do better. And REM's algorithm is unlike the path compression and union by rank story. Or path halving. You can do path halving and path splitting. All three of these things are kind of equivalent stories in terms of what they do for the performance. You need to normally you do one of these three things, and you do union by size or union by rank, right? Path compression does this trick where when it walks up to do the union, it walks both of the indexes both of them at the same time, and it uses an invariant where we only point to things with it normally with a larger ID. I think that variant on things is dumb. I go to smaller IDs, that way I go to stable things that don't make me forward everybody later. But you have some direction that we've put on the which will be linked to which. And that lets us like walk hand over hand through X and Y. And then the moment that they point to the same node, you're done. You don't have to keep walking all the way to the root. I think they have a little picture here. Yeah, there we go. So if I walk up through here, I can stop earlier, which turns out to actually be measurably useful. They should have a sense of how much it actually improves things. Oh, they give it, but it's much later in the article. So they go through and they describe path compression or path halving with link by rank as being the traditional two things that dominate most of the field of alternatives, and show that if you use REM, it dominates all of this stuff, including those. And there's a couple of algorithms that are not generally dominated, but overall, the simple little REM algorithm that I was mentioning is by far the simplest to implement and dominates all of the others. Now, mind you, I'm pissing away a log factor, fiddling around with my functional references. So fighting with trying to find the optimal union find algorithm is more or less an exercise in mental masturbation. But it's keeping me excited about the project, or not really, but it was enough to get me to switch implementations. This one down here, which is like 3 links lower, one is this is being smart about using memory, so packing your structure small, which is really hard to do in Haskell, so that's just out. And then IPC is immediate parent. It's just checking to see, the immediate parent check to see if the two parents are equal, and then just calling it a day, because that usually short circuits the checks that are done by disjoint sets. So if you have to do normal union find and you can't accept REM, then that one works. So I'll dump the link to the talk in chat just so it's here. But performance, I'm willing to do a lot for a 50% performance gain or a 28% performance gain. So this is full path compression. Path halving is actually better than path compression, but REM is better than both. All right, so that's union find with a result that's usually not in people's textbooks. Now back to actually our regularly scheduled program. So right now, because my references have IDs, I can exploit that to run through here. And so in theory, I've written this code. I haven't actually run it. We can create a new rem variable by creating a ref. The ref has to reference itself, though. So there, what I'm doing is, so when I made the ref, I put the default value in the ref rather than storing it in the environment. Because the problem is I leak everything that gets stuffed in my environment forever. Right? There's no way to garbage collect this environment right now. When I go to create like a SelfRAF style thing, it's actually kind of beneficial to me to have that be stuffed in the reference rather than have to stuff it in the environment as a second pass. So that's kind of the idea. So new SelfRAF basically gives the computation to put the thing inside the ref access to the ref to build the initial value. And then it uses recursion and the fact that we're lazy to spit out a result.
I gotta grab some
Caffeine.
of the stash because you're out.
All right. I don't think it's as bad as Chrome. I don't have 3 gigabytes worth of data to leak. I am now covered in Diet Coke. All right. I'm gonna move this laptop over here. It is very full of ice. What do we have here? So we've got these new SelfRAFs. So yeah, this is basically build a reference that points to itself and then call that rem. Eq here is comparing 2 for equality using find. Doing the find right now, I'm using path splitting. I should use path halving. This was the first one that I wrote. And then union is the workhorse of rem, and this was me transcoding rem's algorithm, but with an actual functional reading. And in theory, this should be right. So now what I want to do is make like sort of the main reason for having these at all is to start building some SMT theories. I need to get SAT in here, which is a whole other step, which is I need to get conflict-directed clause learning and all that stuff and the normal SAT machinery built. But one of the things that I really want to get built in here is e-unification and congruence closure, which are like Nelson-op, and the main trick there is like I want the theory of uninterpreted function and the ability to compute equivalence classes of those. And for that, I need this. The other thing that I'm kind of playing around with is implementing nominal unification, which is actually the point of all of that tangent that I was building the name library from. And once I've got that, basically what I would be doing is doing union find, where what I would stuff in, I could stuff a permutation in each node and then concatenate the permutation to the root. And you pick up apartness conditions and unification constraints, and that is a unification solution. that should be enough. So, basically what I'm looking to do is like modify the union find stuff to have some group that I can stuff in each node, so that when I link something underneath another node, I keep track of like the group that I need to get to the root. So I when I link into somebody, I pick up their group value and join it with mine. So each reference has a, well, you can do it with a monoid. If like each group has each reference has a monoid that links it to the root node, which is like the canonical choice. And then I want it to be a group because that way what I can have is I have a group that lets me describe how I get to the root, and I have like the inverse that describes how to get back down, and that lets me take any two members of the equivalence class and describe the group that turns one into the other, like the group that acts on it to turn one into the other. But that's sort of the idea of storing some kind of group structure in my references. So I have these references. I need to build the theory, like I said, E unification and see if I can get E unification and uninterpreted functions. I think there's a SMT EUF. Yeah, there's Leo tomorrow. Hi, Leo. This is simple SMT with a conflict directed CDCL sat solver, and then you build the theory solver. The problem is right now the approach that I'm using, we started from a theory solver, and now we're trying to bolt sat onto it. Normally what you do is you use a sat solver to like enumerate all the ways elements of your base theory can be like put together as true or false, and then you use the theory to add a little bit of extra propagation to that. The problem with sort of the Canron/Guanxi style search is that I'm starting from like this sort of DPLL-ish search, which is just sort of do the entire problem space. And I can build a theory solver on top of that, which basically has been done by the Canron folks many, many times. The problem is that the base solver can't do the non-temporal backtracking, and means it will always be inferior to an SMT solver for at least the SMT bits. I think you can see that. I think they have a version of that somewhere in these slides. Not really in these terms, but I think they gave a description of it. Basic approach to SMT solver. Yeah. Yeah. Here was the reference to the fact that if you're dealing with Boolean structure, that it can explode, right? Because if you give it, you've got a formula written in disjunctive normal form. You've got several literals that you share. You want to avoid recomputing those over and over and over again. So the general idea is use the sat solver first. I'm trying to get away from that. One of the things with Guanxi is like trying to live in the Canron clone and then bolt the extra things on. And one of the ways to do that might be to be smarter with our use of environment and our like continuation reuse. So right now, it's basically a gigantic state monad. In the applicative fragment, it would actually make sense to, when I run this computation, like if I like have an app of something to something, if I run this computation in like some initial world, I could keep track of what portions of the world I used, what variables did I read from, how many variables are active, what have you. Like if I did threshold reads, which thresholds tripped. And then when I try this in a different world, if those same thresholds are tripped and all those values, all the other, like if I do naive reads for everything else, I could immediately replay the results and apply the change to the environment. So this would be like the update monad story. I think I might have included it in like a questions.txt file or something like that for this. Yeah. Is there an update monad story? So in the Guanxi, there's a question repo. There's a questions.txt file that describes kind of like the general research direction that I'm interested in going in. So I think that update monad story sort of addresses the same thing that building your SMT solver on top of a SAT solver does, at least in some of the code reuse stories. It doesn't get you non-temporal backtracking. It doesn't get you all those other things. Now the question is can I bolt the non-temporal backtracking onto Guanxi by saying, all right, we've got in universe, we've got a shared environment. Across universes, again, a universe is going to be whenever I backtrack. Across universes, I can share the clauses I learn with any other universe that like contains the clauses that cause me to backtrack. So now we have, so we're picking up layers and layers and layers now. What do we got? We have a base monad, which is like ST. Then we have a state T of that of like my SAT environment. Then on top of that, we have a logic T layer. Then on top of that, we have another state T layer. And this layer is adding the cell environment for my ultimate monad here, which we'll just call FDM or something like that. Or G of M. Then on top of that, we have the par monad, which is really, like I said earlier, a concurrency monad. Then on top of that, we should actually be building the par machinery. So this par monad gives me the multiple threads within a universe. So let's call that conc. And then we would put par on the outside of that, which would give, or like some kind of worker work stealing system on the outside of that. So this is what it's looking like. GSA is something like this. Blah. The ultimate monad that Guanxi is probably going to wind up running in for the most part. Now, do I need all of these parts all of the time? Maybe not. I could probably get away without the outside par layer for most of these applications, at least until I determine that it's really useful for scheduling this stuff. But that's the general shape of this monad, which is kind of daunting. I would like to collapse some of these layers down. I don't really like the fact that if I look at logic T, that is CPS'd, but then par is also CPS'd. I should only have to CPS once. So there's a lot to do to smash this flat into something that's tolerable. So as Quantumblation was saying, can I build the simple thing and then show what it actually, where I actually get benefits from doing all this stuff? I don't know that I can. And part of it's because it's a lot of pieces to throw up in the air. And keep in mind the cell environment is two environments, and the the conc layer here, or whatever the par that I'm actually using right now, also has a state, which is the set of active tasks. So I have 4 states, a base ST monad, yeah, it's horrifying. So right now I don't have this outermost par layer, and I don't yet have this sat layer in the middle. But if I otherwise look at this thing, this is my FD monad, where I've got par layered around a state that's providing me my cell environment, wrapped around logic T, wrapped around ST. But the thing that I kind of want to do here is not just use state T for these, but rather build some kind of update-like story where I can have a smarter applicative. So that probably will wind up being another little monad in its own right here, right? When as soon as I can figure out what the right way to describe it is. By the way, I did warn people. I tried to warn people that this is going to be a fairly exploratory series, so not everything is going to yield immediate results, and I'm not in like full-on tutorial mode. So I warn you now, if you did not get the warning earlier. But that's the general shape of the monad. So as I was saying when I was describing the project, Kanran is this beautiful minimalist thing, and Guanxi is anything but. It's this, yeah, it's heading in a horrifying direction. And this is before I had any of the abstract interpretation machinery to try and make it faster. But the nice thing about having so many orders of magnitude on the table is that I can afford to spend them on constants. If I can derive benefit on pruning the complexity of the complexity class of the problem. The downside is that in practice, NP is the new easy. SAT is not that hard. SMT is not that hard, and so the constants, when you're given a good solver, are not that high in the first place. So I'm kind of hoisting my own petard there. So we'll see. As a result of this, the main thing that I'm trying to get out of this is a framework for thinking about this kind of programming. And if I have to turn around and like take the life lessons learned from this and then build the super engineered version of it, I think that's acceptable to me. So on the other machine that I have here, I was playing around with switching the whole guts of this to backpack. And I don't know that I like the direction that was going, which is one of the reasons why I haven't shown it here. I also haven't committed it to the Git repo. I should do that. Although all my machines are now backed up. I went and set up everything with a little backup provider. And so hopefully that will keep me from losing data again. Kind of shut the door after the barn door after the horse fled, but let's, actually, I can pull up the code on the Mac. Let me just switch laptops completely midstream here. Let's see if this works. Hopefully I don't lose the video. Switching machines. So playing around with backpacking the whole project. I get Come on, no whammies. This was my fear. Unplug the video. Plug the video back in. But I had to try it sometime. Display preferences. Back. No signal. This is not good. Seemed like a good idea at the time. Don't actually know how to reset this video while I'm on stream trying to use it. That is annoying. Either I will need to buy another video capture card so I can switch between machines freely, or I will just have to stay on one machine for the whole stream, which is probably what normal people do. Come on. Oh, progress! Holy crap! I have a machine. Can I display separate display? Okay. Now whichever way it put the desktops. Progress. Back in the chat, I lost whatever was said in the chat when I wasn't looking. Some references quit. So the only problem is I lost the little VS Code thing above my head telling me who I am and what I'm doing today. So in this little backpack branch of Guanxi, I haven't finished porting all of it yet, but the current thought was to go through and see if I could organize things into little layers where maybe what I could do is try and figure out what it's not even like a backpacked MTL, but what it would look like to have a sort of backpacked monad transformer stack where like the base layer is a signature that we depend on, and then the next layer up provide two more layers that could be used. Like I said, I'm not so sure that I'm sold on this design. I was mocking it up as a way to like test out like my freshly restored Mac. And mainly because I couldn't sleep the other night. So what do I have in here? So if I look in Logic, we have what do we need out of the base monad? And right now it's M it has to be a monad. I've got this funny little S parameter here, which is going to be like, because I'm almost always going to be working with some STS. I have some hope of using this pattern as a general way to, like, if I were to try and build a monad transformer in Backpack, I would have a problem. And one of the problems is this: you can't talk about st as a base. You can't, like, if I were to use this pattern without some wiggle room, I wouldn't have any place to put the s for the sts in the monad transformer stack. In particular, like one of the things that was happening with the FD monad is that I had this FD parameter being plumbed all the way through. I had like a ST layer, and I was logic T'ing that. But then when I went to build the state also referenced S. So this is kind of a general pattern that I'm finding, that whenever I have something that I'm going to have to like use the region parameter trick from ST, the backpack tooling gets in my way. So here what I did was I just baked it in. And I'm somewhat hopeful that what I could do is I were to try and do backpack like state and all those kind of things as monads, so that when you built the resulting monads transformer stack as a pile of like layers of backpack, everything would be inlined all the way out, and we would get to know all the details of all the types, and everything would be able to monomorphize, and I wouldn't have to rely on inlineable and specialized pragmas everywhere. That if I did this in general, where what I do give everybody is some free parameter, then maybe what I can do is use this to build this in general. Now I might need some constraints, like a type family OK, which tells me that this should be OKS is a constraint on whatever kind S is. Like I might need something like this. So OK should be a constraint that we put on S, and then if you have an OKS, then this is a functor. This is me sketching. And then if I wanted to build like state T and then use it through the MTL, I would like use this S to hold on to both the S and the M that I'm built on. The idea is like how could I backpack to learn things about layers where this, like when I'm working with state where the S might have to be a region parameter, I would have to infect everything in the backpack module with like this extra bit of information. And this S might be enough for me to be able to do that. So that's kind of the sketch. So here what I've got is logic T reflection, but now this itself can be used as such a module because it has a type M, which is the local logic type that I'm defining. And then inside of here, I use the base monads type as base. I think Henning Thielemann would be really happy with this style of Haskell. It sort of converts it to an ML-ish story where everything should be C's and T's. I'm not too happy with it. But this was a fairly mechanical transcoding of the existing logic T code. I don't know that I gained anything from doing it to logic T, though. I did get something when I started building like this little par layer, or futures. In futures, what I have is I have the base monad. And I know that I have some monad that has a fork, a halt, and a yield. But then when I go to build my promises over, I get, in this universe, I've already renamed var to signal. I'll probably wind up doing that in the main branch because I kind of liked it. The nice thing is like if I compare this against the other code, like I've lost all of those constraints. Like everything here is monomorphic. It's not just like it gets to know the particulars of the dictionary. This gets compiled once against the concrete monad transformer stack, which is both good and bad. I've lost some of the delicacy of like knowing exactly what I needed inside of the method. On the other hand, everything is completely monomorphic, and then by the time this thing gets done compiling, it's going to be nice and clean, even in the recursive code. So I kind of like that. This I gave a talk on using monad homomorphisms rather than like the MTL approach. And this sort of speaks to that part of me. Like I'm writing against something concrete, and then the backpack machinery is picking the architecture of the program for me. It's really like kind of a second-class citizen story, though, like where you have to like compose all of the modules together, and then you can work. So yeah, once I've built, but I have to build up my notion of references. And the other nice thing is these signatures wind up telling me exactly what I need out of the previous layer, whereas previously, like I had to read the entire source file, and it was this big mess. This is like the signatures do tell me. I mean, this is not surprising to anybody who does OCaml. Like signatures do tell you a lot about your code. The thing I don't like about OCaml is the need to plumb them, which is of course by moving into Backpack, the thing that I'm forcing myself to do. So what did I need out of refs? Well, I needed the ability to create some reference type, and for my monad, I needed the ability to construct a new reference, like to be able to compute the reference ID, all this kind of stuff. I lost the ability to just talk about ref using the pretty lens vocabulary, but I think it's an acceptable compromise if I were to go this direction. I don't know that I will. And what do I need out of signals? We were talking earlier about scope and aim and fire and all that. Here we can now see the forest for the trees. So we have signals, and all I have about a signal is that I can show them and tell you which signal I have. I can construct a new signal, which either doesn't do any finalization or does. I have the notion of some set of signals. I don't know what it is. It's just an abstract data type to me that is a monoid, and that I have things that have signals. And at least signal has a signal. In this setting, proxy has a signal. So you can use proxy as unit for like build the empty set of signals. And then scope will delay all calls to fire inside of it. We can fire anything that has signals, which will like trip all the propagators that are blocked on any one of those things to go look at their inputs. And then propagate replaces new propagator underscore with anything that has signals and grounding. So this is what I'm kind of switching the API. This is one of the reasons why I wanted to go over here and look at this code, is because it's much easier to show sort of the whole API. The Haddock-like story here is really clean, because you're not like drowning in 50 constraints on M. I mean, that's one of the reasons why I like Backpack at all, despite the fact that it gets into a very un-Haskell-y style of development, is that when I go to build, in this case, the whole layer of all the stuff I need for futures and promises, the promise code is really quite quiet by comparison. So this compiles as much of this as I've got written. I don't remember how much of that is. I have like the common library, which has like the aligned and unaligned types, the environments keys. We have this logic layer, this feature layer. I have a little ST monad layer, which builds STS as a choice of M. And then I build like, instantiating logic on top of ST to make sure that this is an instance of this pattern. And then I'll need to go through and like prove that CPS and reflection are instances of logic. I need to build the par layer and all that kind of stuff. Like there's more to do here, by far. There's a bunch of annoyances with this approach, which is one of the other reasons why I'm not too happy with it. One is I lose my doc test suite because I need custom builds in order to build the doc test suite. At least in order to build it safely. And And I can't have custom builds if I want to have multiple libraries. So that's a place where Cabal is kind of falling apart for me. What else do I have here? Yeah, I think that's the main thing that's kind of a pain point for me. Like the other one is that I don't know that, at least so far, that I've gained any benefit of moving from the MTL-ish story to piles and piles and piles of these things, other than the fact that I've ditched tons and tons of constraints along the way. Without losing, like normally what people will do is you'll find a lot of people in Haskell who will just write against one particular concrete monad, and that's a legitimate way to work. The problem is you've lost generosity. You've lost like a lot of power to work in other like transformer stacks and what have you. You incur constraints you don't use, etc. Here, what I like with the backpack story, I seem to have the ability to regain the generosity. Like you could instantiate this tower of backpack layers where I've defined what logic is on top of some base monad, and then like I'm just choosing to build the ST logic layer, and then all of this other code works from there. Like it's like picking some particular concrete choice of monad M that I'm going to work with throughout my whole program. But where I have the option to link against different M's, I guess is really the idea. So this is the backpack form of this. I think what I'm going to do is stick with the other universe, which is on the Windows machine here. This was an interesting thought experiment. I may commit it if I can get more of the like stuff to actually just type check and like work as a branch. The main thing I think I'm going to take away from it is like the incidentals. Like once I could see the whole API, it was much easier to see that the user never actually needed to care about propagators. They just needed the propagate functionality. And then the other one was that var was a really stupid name. So I think that is the main takeaway that I got out of this little deep dive spike solution for 3 hours the other night when I couldn't sleep. I'm still open to doing this. Like if, in particular, if like the soup of constraints that I'm using, which is not going to be fast at all, proves to be a real bottleneck, I'll probably switch over this for performance reasons. Yeah. All right. I'm gonna go back to the Windows machine because there's nothing really on there that I need. Now here's hoping that I can get this thing to... Oh, wow, that was fast. And I have my chat back, so... Anybody was trying to talk to me? No, no one was trying to talk to me. It got really quiet. Let me pull up the status of the stream. Hello, Alex. And yeah, folks are sleepy today. I mean, it's 11 p.m. or 10:30 my time. I lost the code window. There we go. Ooh, all right. Now people know what I'm working on. Clearly that was the problem. So I think the main thing that I need to do next is start working on getting e-unification implemented. That's going to be taking Rem's algorithm that I've got there apart and bolting a little more like, cause I want unification and disunification constraints, which is basically so let's do it without functions for right now, because that's probably the easiest way. So right now rem is just hanging there without any stuff in it. So what do I need? I need the ability to smash these together. Yes. And I want a val, or a var, in here that can be used to push whenever like more things got unified with you or something. Rem's algorithm might not be the right solution. I might need to just switch to like union by size or something. But so that needs vars. I'm kind of tempted to go back to, I was saying earlier that I didn't like the cell vocabulary. So what do we need here? I have a propagator, but like users never need to see this thing. New propagate. I kind of like the new propagator underscore as propagator or propagate. I had renamed var to signal, and I liked that. Yep. All right, that was tough. And users never call aim. So we've killed aim. We give users fire. They have the ability to construct signals. Syncs can be punted out to another module. And when I need them, I'll bring them back. Haven't used them yet, so sign of where I put the big comment out block of sync. Great. Cells, I need to just call that signals or something. It's a terrible name. And then this has all the contravariant stuff. Divisible, decidable. And yeah. back. Syncs are gone. The idea of cell IDs is kind of messy. Cells and cell environments, these are all guts. Users never see propagators. They're kind of invisible, and they're talked about implicitly through cells. Cell is maybe a data type, but the users don't need to know about it. Yeah, I'll stick to that has signals vocabulary. That's pleasant. Okay. And then cells is going to become signals. I'm going to call it a new type. New type signals, M is just an inset. Instance. User works with signals abstractly, doesn't get to know the details of it. So the ability to construct new signals, fire a signal. Maybe it's raise, I don't know. The ability to call ground, which makes sure that everybody has been reduced to its ground state. And then the concept of cell environment is a plumbing thing, which needs to be visible. The default cell environment, I'm just going to encourage dependency on data default. This default, whatever the hell thing, is getting old. My principles can rot. And then no one ever sees a propagator again. Wait, propagate. Is there? That's the one thing that we kept out of the world of propagators. And that's the new ref cell, although the name is, the module is now getting really out of date. Divisible doesn't need to be used here. Apparently contravariant, but doesn't mean it need to be used there. Cell is now signal. And we have sync. Build everything. Tell me where it went wrong. Caps lock, that's what's going on. Alright. Cells. goes from kind star to star. Deriving a GND. So this is the change. This is no longer unit. This is proxy S or proxy T. Signals T. I have to be careful because this is no longer this determines this. I should be able to use proxy S. What this is a determines thing. I don't need anything magic there. Has signals. Import data proxy. Since it has signals, signal M. This is the M here. Guess what I can do? I can make signal. Yeah, signals is signal M. Hey, Puff and Fresh. You got your choice of emoticon. I think there's a second one, but I think because we could only have one at the first tier, it's on the second tier. I don't remember what Amy called it. That's the one. Because I can use it. Is it? Yeah. I couldn't remember the name. I was looking for a short name. Oh yeah, I guess it is. That's the whole thing. It's a racket. I'm trying to rack up the Twitch bucks here. Has signals V. Has signals MV. 175. Have signals M. Have signals M. 187. What do we have here? Propagate. I don't have new propagator. I do have new propagator. Oh, this has the M constraint. This is a signals of that. 170. My old thing on semigroup subclasses, and it says you're online. What am I drinking? This is Diet Coke. Why is the MTL still a thing? Because all of the alternatives are worse. Has signals. Cell IDs of. Oh, I need this. I've never seen a skinny person drink Diet Coke. Well, that's true. And 170. signals v. I need to make the ability to extract the get signals. Smash that together, and we're back on off to the races. 182. Where did I go wrong? Inset to list C's. But I need to construct a new one. C's, propagator act. Get me the signals, get me the signals. To list get signals. 31, where did I go wrong? Where is it? Our promise, please. You are new ref nothing. What? I must have I pasted two lines together by accident by hitting Shift J when I had my caps lock stuck. I need to turn that crap off. New machine. Life lessons learned. Var becomes signal. Yep. Legal type signature on par promise. Line 31. Oh, more lines that got smushed together. Has cell env. New propagator became propagate. Hey, Iceland Jack. Were you able to catch the video from Iceland? Kind of silly to me that I went up there like, I'll do this thing because Iceland Jack couldn't make it. And then you were, where were you anyways? You've said something somewhere to somebody. I've forgotten what it was though. Promise has signals. Unit. There's a proxy now. Import data.proxy. Sweden. That's I knew you were somewhere. Like, not Iceland. Has signals M proxy T. I had this problem in the other one. I need to get the information to flow both ways. Oh, that's why I needed it. Signals. So I know M, but M isn't telling me T. Has signals M proxy signals. M is N. This lets me mash the two together. It was mostly because I had a deriving via thing, and I know you've had a lot to say about driving via in the past. Has signals MN58. Why are you not getting anywhere? Propagate V, proxy. For all MSA, go. I was originally going to talk about Coda, but no idea what a monad is. A monad is a monad in the category of endofunctors, as people like to say. It's anything that satisfies a few little laws. It's a pattern that people use over and over again in Haskell to make like the semicolon inside of this do block like programmable, so you can give it like different meanings. There's lots of little statements like that I can make about a monad. In practice, it just behooves you to go read a monad tutorial or like chase after Puff and Fresh videos. I think that's a good suggestion. Scoped type variables has signals. Propagate v proxy. I need to v should tell me it's a var m. Signal m, which should have told me one of the variables. I should not have to say proxy m. I should be able to figure that out. This bothers me. The reason I wrote the superclass constraint on the proxy version of that was explicitly to get information to flow from M to proxy so they could learn what the type of proxy was. I don't know why that had to happen. Ref cell is next. Where are you? Ref signal. I renamed it underneath us. Data functor contravariant. I guess we were getting it from lens or something before. Has cell IDs. This has signals. This is now a signals of M, which has made this a little more safe. Control monad state in 29. Has cell n. One more argument for signals now that we know what M is. That should just be good. 27. Flexible instances. Scope. Did I not bring scope into scope? That's irony of ironies. Signal. I export fire. Forgot scope. Hi, quantiplation. I think the main thing you missed was I went and switched var to signal and made cell IDs well typed so that they're actually scoped to the monad appropriately. And ref cell var propagator. FBI source par future. Ref cell has become a signal. break a lot of code this way. Next. Oh, this is going to be much more delicate than usual. That's that. Cell IDs as signals. Oh, that's tip for in the chat. FD monad. 32 ref signal. So signal env. Just derive all the things. The world never sees the word cell ever again outside of that one module. That doesn't need it. Define but not use propagator action. It's fine. I'll just not tell anyone that name. Defined but not used. Hey, it's amazing. Nobody uses any of these names. All right. And with that, we're all good. When am I coming to India? I think the plan was next year. There was I think Tony asked me to come out and give a talk at, what is it, Functional Conf or whatever the one in Bangalore was that he likes. So I'll probably come out next December. So I was supposed to go to a thing for, what was it, a bidirectional transformations workshop this week. And then something worked out that didn't work out for travel. So I didn't make it this year. Otherwise, I would be there right now. Instead, I'm here. Replace. Space, star, all of that. I like all of that. And yeah. Cells and signals. Team in Bangalore. Are you going to still be there next year, or are you just going to be bopping around? Are you still streaming while you're in Bangalore? A signal. Alright, that actually built all the things. Ship it. We'll even run tests. Now that I have them. Oh, there's a whole lot of them, but there's a few. I'm fully down to going, or down for going. If it wasn't for this other obligation, I would have totally been there this year. Yeah, I've not had any luck trying to stream from a hotel room or anything. I can't get the data rates that I need. Cool, new headache. Oh, and I'm gonna have to actually reference this from like Firefox or something, because I have to do it from within WSL. See the state of the documentation for this horrible thing. Ah, right. So what do we have? We have aligned things. This lets us build all of the Okazaki style catenable lists, free monads and whatnot. One of the things that I did do was clean up some of the unification code that I had lying around in here. This is one of the places where moving to Backpack would make all of this melt away and be readable. For some definition, readable. I wind up with this little unification algorithm that works over arbitrary free monads in any monad that has references. And I believe this version of the free monad is the reflection without remorse based version, and then I have another reflection without remorse based version that is the free monad that everyone likes to use, which is just rebranding operational. Both of those provide the same unification machinery as a workhorse for building a more interesting unification. We've got our finite domain monad, which currently I've got this par thing bolted in, which I talked about earlier. My cheesy little example, which is a thing I keep going back to. My finite domain variables, which have been finally ripped out of that example, which we talked about earlier. The 3 or 4 different implementations of the logic T. Currently just using reflection, or the naive one, I don't remember which. Par itself, halt. It's really kind of annoying the way this thing does default signatures. Do I get an improvement on that if I update my version of Haddock? Haddock 222.0. What's the new version? 222. Well, I guess it's not getting any better unless there's a new version on. What's head haddock? Haddock. Haddock library. There it is. Haddock library. Where's the haddock executable? There it is. 2220. That's the one. Alright. Guess they're not showing default signatures any differently. Just drilling in on a annoyance. So in par I've got futures, I've got promises, I've got my par monad. This rem thing's working. I started this little toy tactic thing, which was just me playing around with, can I make a nice little monad for working with tactics. It's really kind of minimal right now. I should have done that with hyperlink source. What's the haddock hyperlink? They'll probably demand more stuff from the world. Nope. Because it doesn't need anything funny. I thought it had to compile HS color or something. There, I can find links to the source code. So this is just like a silly little CPS monad of what do we do if we succeed? What is the failure state of this tactic? And here is it refined to a sub goal. So then a tactic followed by another tactic, like refines by one and then refines by the other, assuming that this thing actually made it to a sub goal. And then repeatedly is drill in using a tactic. So this gives it like a tactic combinator basis, which isn't terribly exciting. I believe George Necula had some slides on the topic there. That's probably what happened. But this is sort of me just sort of fleshing out, like, this is another layer that's picking up yet another layer of continuations though. And so I'm kind of beating on this to see how bad the problem gets before I have to figure out how to smash all my different continuation passing tricks together. But otherwise, this is a pretty straightforward, like if you've ever looked at the code of Parsec or whatever, plumb all the continuations by hand. Bit of nonsense. So I think that's the only other thing that I hadn't shown so far that's new in Guanxi. I think the next step is going to be working out the abstract interpretation machinery. So let's see. So things that have to happen in the short term. Getting the abstract interpretation machinery in here for working with octagons. Figuring out how to do the CDCL SAT bits. Finally needs to happen. So that I can start looking at abstract CDCL for all those other abstract interpretation domains. And this update monad thing is really starting to bug me that I haven't done it yet. One of the reasons for getting the par stuff in at all was so that I could talk about threshold reads and have a good use for the update monad. As I sort of fork the world and then use the update monad to try and glue things together. Anywho, I think that's a... I'm not exactly sure how long we've been running tonight. I think we've hit a pretty good stopping point, though. Yeah, I think I'm going to call it there. We'll pick this up another time. I'll close that. Thank you, folks, for tuning in. And D-Bus is yelling at me. Oh, that doesn't matter. Alrighty. Well, have a great night, folks.